So this is from the Shua deposit in Ethiopia. It is a perfect harlequin, and it appears to be stable. We'll let it sit and see what happens. Isn't that lovely? So, 36 carats. Most of it's, the shell. So there's about 20 carats of top gem, black opal in there. And it's a perfect harlequin. Which is the most sought after pattern. And that's bright gem color. So the other thing I got on the way home was some new dirt from the side of the road. This was we stopped at Star Tower on our way home. Star Tower is kind of the neighborhood's flagship. It sits out there on the way in from town, and through the mountains, and we like it. We stop there and look around. And this is this was a hole there. This was not even where water flows, right? My wife just went and scooped up a bunch of it. And so what I'm going to do is clean it, see what I get. It's fairly clean dirt. It's not like dirty dirt. And there's a lot of gravel in it, obviously. Hold on. Okay. Little magnet here. And, and we have AuPt and, semi-magnetic gravel of various types. It's granite, right? Granite is mostly AuPt. Who knew, right? That's not what it says in the books. But, there are some tests that you can't fake, man. Like picking up granite with your little magnets. That's what we're doing here. Because granite is mostly AuPt. Mostly AuPt. That's what it is. Doesn't matter how big it is or how small it is. Those mountains behind me, all of the granite in those mountains is AuPt. It's not all magnetic, but it's all AuPt. In one way or another. There's a lot of aluminum oxide, but there's also just a lot of AuPt. Most of it's AuPt. How about that, huh? It's the only gold stuff that sticks to a magnet. Ha 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 ha. So this is just like dirt from a hole, right? There's construction going on there. And we stopped, and my wife, not walking real well yet. She's got a brace on her knee, so she can't bend her knee. She doesn't want to walk more than about 3 feet. And I don't blame her. And that's about how far she walked. She walked over, scooped this stuff up, and apologized for getting so many rocks. Because I just asked for sand, but that's okay. Because I get to look at the rocks too. If you look at these, see all that shiny silvery stuff? That is platinum. That's platinum. It's not like mica. It's not hornblende in there, those little black things. It's not separate crystals even. It's all one thing of AuPt. And the mix changes. It can be all of one or all of the other. And you'll find a lot of these have half and half. It looks like it's half gold on one side and half black platinum stuff on the other side, like this one. See, I just picked that up. I started talking and just picked it up. It's a random sample. All of these are random samples. And what you're looking at is a high platinum granite that is primarily AuPt, gold platinum alloy. And you can grind it up and turn it into concrete. That's what concrete's made out of. So you could go down to the store and buy concrete probably and melt it at 1768 and have gold platinum alloy in whatever mixture it is. Isn't that cool looking though, huh? It is cool looking. So one of the problems with people looking at granite is they're not interested in it because it's not worth $1 bazillion, right? So they pick it up and they say, oh yeah, a bunch of little crystals. You know, and they see a bunch of little things in there and little sparkly things, and they say, oh yeah, and they throw it back. You know how I know they do that? Because that's what I did for about 35 years. This thing with looking at little brown rocks is a relatively new development here at the Carew House. and you know, it's not because I'm crazy. It's because these tests keep coming up the same every time. And AuPt is a superconductor for magnetism. It passes magnetic energy without resistance. It's a room temperature superconductor. So it's not just sort of important. It's not a value of some number of paper dollars. See, there's some iron in there too. The black stuff at the bottom that's kind of poking out like a flower there, that's iron. There's not much of it. It's way at the bottom. And it's what hits the magnet first. it starts, it gets pulled out of the soil. And you've probably seen iron filings before, and that's what you're seeing there is iron filings. But not the gold stuff, of course. The gold stuff is AuPt. But that right there, out of all that I was messing around with, that's all the iron that there is in there. Cool, huh? Most of it's gold, platinum alloy. And you don't actually like have to grind it up because the dirt itself is AuPt. This stuff here in the desert where I live. See on my fingers? That's how I started knowing that it was some sort of precious metal thing. I'd see the sparklies from the dust on the clothes of that I wore when I was out digging rocks up. And every time I pick it up in my fingers, it leaves those sparklies and when you blow this up, you get closer and closer and closer. And you start to see a cubic pattern in the dust itself. And that's what helped me figure it out. Because that dust is self-organizing because of the magnetic field created by platinum and gold. Platinum has one fewer proton-electron pairs than gold does. So there's a difference in charge of 1 electron volt. And that's sufficient to make every magnet that we ever knew about up until about 20 years ago. All magnets made out of iron are made with the difference of 1 electron between Fe2 and Fe3. One has 2 electrons, one has 3 electrons, and that difference, they're both iron, but that difference is what creates the magnetic field. In magnets, in most iron magnets, and the loose things like these are neodymium, and it's some sort of ceramic. I don't know how they make it all shiny like that, but anyway, it's a ceramic, and they break pretty easy. This stuff is not really magnetic, it's diamagnetic. Primarily diamagnetic, and the cubic structure that you see is caused, a lot of it, by the opposing force to an applied magnetic field, because the AU and PT create a small magnetic field, but they're both also diamagnetic. And so there's this opposing force keeping them apart. And that's what you see here. That's what creates that cubic structure. Because they're just little cubes, one after the other, and they all line up in perfect little rows and columns because they're all basically the same size. Okay, and so they occur in face-centered cubic hexagonal symmetry. And if I look at the cubes this way, I can rotate it 90 degrees and see hexagons the other way. It just depends on which way you're looking at it. And this is primarily, almost all of it, the whole entire weight of this random sample my wife grabbed off the side of the road out of a hole is mostly gold platinum alloy. And we can go through this entire thing, and that's pretty much all we're going to find here. Pretty much all we're going to find. Some organic detritus, not much, because we live in the desert, and a lot of this stuff is radioactive. The desert here is not caused by lack of rain. The lack of rain is caused by the lack of plant life. The lack of plant life is caused by the excess of radiation caused by the KT extinction event and all the volcanic ash it left behind. That's what this gold-colored stuff is. It's the volcanic ash from the KT extinction event. And there's hundreds of meters of it all around the world, around the entire world. Hundreds of meters. Mostly we walk around on top of it. Like this in Star Tower. We're constructing houses and towers and all kinds of stuff down there. Blowing it up and there's more platinum in this stuff than the world has ever seen before, because everybody thinks platinum. My father told me that platinum is 10 times more rare than gold. And it turns out it's about the other way around. There's actually a lot more platinum. That's what that is right there. That's platinum. Isn't that beautiful, huh? So they make cubes. They make cubes with hoppers. Hoppers because they're face centered, and so that means they have like dished out places. Places like basalt has, right? Basalt has those holes in the outer stuff. That's what they are. They're not gas bubbles, man. They're part of the crystal structure of AuPt. And those were extruded, those basalt things. This stuff, granite, forms underground and it cools slowly. And the deeper it forms, the bigger the little cubes are. But those little cubes are not separate things. They're not separate crystals. It's one thing. And they all line up in rows and columns. Because it's one crystal of AuPt. How about that, huh? And it's not just one of these pieces of granite, it's all of these pieces of granite. Many of them stick to a magnet. And, I might be crazy, but my magnet's not. My magnet is not crazy. So there it is. Ha ha ha. AuPt in vast abundance. We can make our metals out of AuPt without having to destroy the earth to get them. Right? You can just scoop up the dust and use that dust. It's already just about pure, and it's actually stronger than steel. So we can use it structurally in thin sheets and heavy, but it's strong. And it's not rare or hard to find at all. There's enough for everybody to have as much as they need, and leave it for our children without destroying the planet to get it. And that's important. Peace, y'all.